Hi, have a good day to our lecturer, Mr. Chiang Ipin, and all my group members. We are from PEM2415B, Group 6 Ultra Brothers. My name is Muhammad Faris Hazwan, and for today we would like to present about our short video of the experiment Thermalfluid Lab pressure drag of a flow cylinder.
Hi, my name is Muhammad Ashraf bin Muhammad Jaafar. I'm from 6 Ultra Brothers. My ID number is 2030970287.
Hello, my name is Muhammad Fawzan bin Azhar and I'm from Group 6 Ultra Brothers.
Hello, my name is Muhammad Azman bin Jaafar.
Okay, so hi, my name is Muhammad Farhan.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Afiq Zakwan bin Muhammad Osman. Student number 2018-226-656.
Okay, I would like to present about the introduction of this video. External flows past the object have been studied extensively because it have many applications. For example, aerofoils are made into a streamline shapes in order to increase the lift and at the same time reducing the aerodynamic exerted on the wings. Flow past a blunt body such as circular cylinder usually experience boundary layer separation and very strong flow oscillation in the region behind the body. In certain Reynolds number range, a periodic flow motion will develop in the wake as a result of boundary layer vortices being shaded alternately from either side of the cylinder. The periodic nature of the vortex shading phenomena can sometimes lead to unwanted unstructural vibrations, especially when the shading frequency matches one of the resonant frequency of the structure.
Hello, my name is Muhammad Fawzan bin Azhar and I'm from Group 6 Ultra Brothers. And I will talk about the principle of the pressure drags of a flow over cylinder. The pressure drag is generated by the resolve of components of the force. It is due to the acting normal to the surface at all points. The pressure drag is computed as the integral of the flight path directions components. The function of the magnitudes of the pressure and the orientational of the surface. Hence, the pressure drags is a pressure is flow normally in the flat plate in the entire drag.
Okay, so hi, my name is Muhammad Farhan. So I will be sharing with you about the principle of pressure drag. So according to Bernoulli's principle, so faster moving air exerts less pressure. Okay, this causes that there can be a pressure difference between surfaces of the object. So the general size and shape of the body are most important factors in form of drag. So in general, bodies with larger cross-sectional will have a higher drag compared to thinner body. Okay, as you can be seen in the figure, the drag force arises from the difference between the pressure acting on the front and back of the immersed body.
Okay, I would like to present about the apparatus that we use in this experiment. The first apparatus, as we can see in the slide, is circular cylinder. The circular cylinder in a low velocity wind tunnel. The cylinder was contained a hole and it was connected to the multimeter manometer to measure the pressure cylinder. The second one we can look at the slide is the wind tunnel. Purpose for educational users. The wind tunnel consists a wooden fan to pull the air from the laboratory, passing air filtration stages where the tunnel was converged and diverged until we get the uniform steady flow. And the third one we can see is multitude manometer. Multitude manometer used to get the pressure of the wind through the flow of the cylinder.
Hi, my name is Muhammad Ashraf bin Muhammad Jaafar. I'm from Sis Adras Brothers. My ID number is 2030970287, and I will present about the experimental procedure in my presentation lab, Thermalfluid. The objective of this procedure process, the fluid that have been flow was be tested as viscous. Viscous flow over a cylinder would not be set apart, but viscous flow split up due to increased whirlwind and measurable increased pressure or velocity. The pressure coefficient is monitored as ordered pressure force PA plus half rho A times VA squared equal to pressure plus half rho VA squared. And how to get a coefficient pressure is equal to CP equal to P tolak P minus PA divided by half rho VA squared, and the differential of pressure is P naught minus PA equal to half of rho VA squared, and rho VA squared equal to rho G times differential of H naught equal H naught minus HA, and CP equal to H minus HA divided by H naught minus HA. And what is the HA? HA is the static head from a wind tunnel, and H is static head at each angle, and H naught is static head at theta. For this experiment also, we have implement two types of velocity, which is 10 meter per second and 20 meter per second. The first step, the wind tunnel will be run by passing the pattern with using software, then record the multi-tube manometer reading during stability of velocity. The reading will be indicated from 0 angle till 180 angle with H naught is 348 mm. If the result is above H naught, the pressure will be negative, and result below H naught, the pressure will be positive value. That's all from me. Thank you.
Okay, now is the sample of the question for test 1. Okay, we use only the data for one only. Okay, given is velocity. The velocity is 10 meter per second. Okay, and H naught. H naught is 0.002 meter. The initial water level is 0.350 meter. The density of water given is 997 kilogram per meter cube. The density of air is 1.225 kilogram per meter cube. And lastly is gravity. Gravity is the value of gravity is 9.81 meter per second square. Okay, to search for H minus H naught, H is given, so H minus H naught is given, so for data 1 is 0.002. Okay, for to search for pressure, we need to search for pressure minus subtract to pressure naught. We use the density of water bracket H minus H naught and bracket. Okay, insert the value which is 997 times 9.81 times 0.002 and equals to 19.5611 Pascal. Okay, to calculate the constant of pressure, now we need to calculate the coefficient. Okay, now we need to calculate the coefficient of pressure. We need to divide the we need to divide the value of. Next is to calculate the coefficient of pressure. Okay, insert the value of pressure minus pressure naught and divide it with 1 and divide it with 0.5 times density of air times velocity squared. Okay, insert the value and we get 0.0798. Okay, lastly, we need to find the coefficient of pressure times cos the angle. So insert the value 0.0798 times cos 0 and we get 0.0798.
Hello, my name is Muhammad Azlami Jaafar and I will explain how to correctly do the experiment calculation. For the test tube, the velocity will be different. It will be 20 milliseconds, and we will use same angle, increase a bit 15 degrees, with 30 location. So for the sample calculation, the V is 20. The density of water will be 997 kg per meter cube, and the density of air will be 1.225 kg meter per cube. So to find H minus H naught will be 0.348 minus with 0.349, we will get negative 0.001. So the value will be inserted to find P minus P naught. So the formula for P minus P naught will be raw water times gravity times H minus H naught. So we will get 0.1597, and the CP cost. So the first calculation, the angle will be 0. We will be starting with 0 and increasing with 15 degrees.